Alright guys, welcome to CodeChef, June starters, I assume. Yes, we are back with that kind of contest. It's not rated of course for D1, but still. Last time when we came here it turned out to be quite complicated actually. In the sense that only like a couple of people solved all questions. I don't know how that happened, but yeah. So maybe there's something to learn for us here today. Let's take a look. So first problem, I assume it's first. I think they're ordered at least in starters. So we have a cyclic quadrilateral. That's it. I guess you kind of know what it is. So we're given the sizes of angles. Okay. Of simple quadrilateral in degrees A, B, C, and D in some order along with its perimeter. Want to determine whether the quadrilateral is cyclic. Bro. Okay, yes, it's cycle if and only if the sum of opposite degrees is 180, but they are integers. But how did that oh, okay, that doesn't have to be convex, alright. So this is a simple implementation problem now. Read a couple of test cases. We read our annuals. It's guaranteed that sum of is 360, so all I have to check is if this is true, then I want to print yes, I think. If it's not true, then I want to print no, and that's it, right? Any case will be accepted, that's stuff like that. Okay. Copy that. Oh, I copied twice, but other than that we got no, yes, no, which I assume is all that you wanted from us in that problem. And it's often the case that in like easy programming problems, you would just want to translate this statement from English to code. It's useful not to overcomplicate stuff. Like they even told you when the quadrilateral is cyclic. Okay, so one easy problem done, 5 to go. Next problem is chess match. Blitz 3 plus 2, I assume plus got converted to an underscore. In a chess match A plus B, each player has a clock shows 8 minutes at the beginning, and after every move they get B seconds. Yeah, we know that. We know the rules. Time decreases during player's turn, remain unchanged, obviously. Is 0. The player loses the game. Okay, there is 3 plus 2 blitz chess match. After end turns, turns means okay. Okay, yeah, turns means like plus players. So first player makes a turn and second player makes second turn, etc. Game ends and the clock of the 2 players stop. They show that the players white and black have A and B seconds left respectively, and that after end's turn B equals 2 seconds are still added to the clock of the player that made the last move, and then the game ends. Okay. I actually did not know that. I thought like when game ends, and then there's no extra time, because it's irrelevant, but assume it is kind of relevant for our problem because we'll have to do some manipulations with that things. So again, we have several test cases, more than previous time, but still not that many. NAB, I assume, is the input format. So NAB, what do you want to print? The duration of the game? Dude, how do I restart the duration of the game? Oh, it's 3 plus 2. It's always 3 plus 2. Okay, I did not realize. I saw that A plus B are also parameters. Okay, well, if this is correct, then you can think like initial players there were 2 players, each of them had 3 minutes, each of the minutes is 60 seconds. And we made n turns, each of the turns adds 2 seconds overall, and we subtract A plus B because that's how many seconds we have remaining, and that's it. Answers are 378, 39, and 0. Duration, wait, what? Okay, duration of the match is 0, how is that impossible? Oh, if you don't make a move, you resign immediately, then you get... Sorry guys. I don't get it. How is it possible the duration is 0? They make moves instantly or what? Okay, yeah, no, of course it's possible, but that's kind of strange. Unless it's like in land chess when you actually can move, pre-move a lot. Okay. Yet another problem where we just convert English to code. Good, 2 easy problems done, 4 to go. Sleep cycle, good. What happens? Oh, you can... Oh, I did not know that, so you can create QR codes. Like default from Chrome. So Chef has been studying the human sleep cycle for years. We all do when we don't go to bed on time. Not in the good way though. So he divides the days into L units of time numbered 1 through L. Chef's research shows that his body requires spending only H continuous units of time per day on sleep, and he can stay active during work. However, in the case of travel or any other responsibilities, he may not be able to achieve this ideal state. Next, Chef noted that if he sleeps for X less than H continuous units of time, and then performs some other activity, he can still meet his daily sleep quota, but the remaining time he needs to spend on continuously sleeping becomes 2 times the difference that he did not get the first time. And then this process kind of repeats itself. Well, that's kind of strange, but it's okay. In a string S with length L for each valid I, the ith character of the string is 0 if the ith unit of time is free, or 1 if it's occupied. Can Chef get enough sleep? Okay, the implementation for this one is going to be a little more complicated, not much, but well, s is not an integer. LHS, right? LHS makes sense. Lightness, hue, and saturation. Obviously has nothing to do with our problem, but nice variable names. What are we gonna do? What are we going to do? String can be quite long. So first things first, I want to know I want to group characters in S together. How do I do that is a good question. So I'll append all characters of string. If current character is a free unit of time, I increment the current interval. And for the sake of not having extra catch cases or anything, I will append 1 to the end of the string. It's a nice technique to get rid of corner cases. So otherwise, if there is some free interval that just ended, then I think I want to push it back here. If there's none, then I don't care, so yeah. And probably I want to reset the counter. Sorry once again. Air conditions are generally good, but not always, as we can see. Okay, no, that sounds reasonable. Now, I'm gonna have to be careful because I assume that you don't want to take whatever is your first value. It can be suboptimal to take first because then you have to pay twice as much, which is kind of not what you wanted, right? Moreover, like I think that it's if your window is less than h/2, free sleep window less than h/2, then don't take it, or whatever is your current needs. Over 2, then we don't take it because it just means that double the remainder is simply bigger than we already have, which makes no sense to use, right? On the other hand, if it's less than or equal, well, if it's equal, then you kind of don't care, but so if it's greater, then you always take it. Sorry. That's hard, but we're gonna make it either way. So now we want to loop over the vector we created. Like ideally, you can do it in the same loop, but hey, it's not like these problems are particularly heavy on the constraints. So if our current string is greater than h/2, then probably we should actually phrase it like this. And what does the h get? So it's like 2 times h minus cf, right? That makes sense. And that's it, and that's it. Each is at least is greater than 0, because it doesn't make sense. So now I just print now if there are some slips that I still need, and yes, otherwise, that's it. I don't even have to print my schedule. Oh, that was correct. Hides previous local declaration. That's not a big problem. Assume no, yes, yes, no. Yeah, like actually this hides this, but you don't care, especially because they are semantically the same. Do we submit? I think we do, and it's just a simple problem. Yo, apparently I did not read the statement carefully enough because it says wrong answer. Oh my, oh my, oh my. Absolutely. Like, you're gonna see, like, I made a mistake. I just assumed that we need to take the entire interval, whereas it's not always true. Like, sometimes you want to take smaller interval because you don't want to oversleep. In order to test it, we will have the following extra test case. So imagine he needs 1 hour, but we have 3 hours for sleep. If you run this, then the wait, actually, the last answer is yes. Wait. Oh, because I just provided inputs in the wrong order. Okay, so first goes L. Yeah, you can see that the answer is not, but the correct answer is obviously yes. And with the changes I made, it should be so. Yes, okay. It's gotta be careful sometimes. Yeah, now I got accepted. Okay. So 3 problems done, 3 to go in the middle of the contest with 20 minutes gone. Last time it started similarly, if you remember. Then it got awfully complicated with the last problem. You can probably guess that we are terrible in the run class because we are terribly slow. Yeah, a lot of people already solved 3 questions, so I mean, there are only 2 pages, so yeah. Problem D, Flappy Bird. Chef was playing a new version of the Flappy Bird with the following rules. The bird starts at height h at x equals 0. There are n obstacles numbered 1 through n. For each value I, the ith obstacle is at position xi and has a height hi. For each integer I from 0 to xn, not included, for some reason, Chef has the option to click once when the bird is at x equals y and denote the bird's height at that point by j. If he clicks, the bird moves up. Otherwise, move birds. The bird moves down. Sorry, I'm a bit dizzy today. There is no ceiling, and all the obstacles extend upwards from the bottom and not the other way around, but you obviously can't go below the ground, right? The bird crosses the end's obstacle successfully. He wins the game. 20 point for what do we want to? Oh, the minimum number of clicks required. Okay. Yet another implementation problem. Like if you click all the time, then you hopefully can win. Otherwise, the level is just impossible because there is no ceiling, right? So the only thing that can stop you is are the only things that can stop you are obstacles. And H is initial height, right? Who came up with those names? Okay. I'm gonna call it Y because it's Y position, really. No, it's height. Alright, so we're at the inputs. What do we do next? Like, ideally, we would like to cross each obstacle exactly at H, or do we have to cross it at H plus 1? Okay, we have to cross it at H plus 1. If it's impossible, we want to print -1. Okay. We can solve this problem going backwards. Because, like, if you think about it, let me draw actually, because this is a good one. So we have our x-axis, y-axis, the original somewhere here, our bird. Now there are obstacles. Some of them high, some of them not so. If you now actually have the Flappy Bird is solved in the meaning that have the bots play it very well, know that each obstacle creates a shadow where you can't be if you want to get past this obstacle. So that is pretty much how bots work, Flappy Bird bots. So once you create all shadows, you kind of know where your bird can go, and if you know the physics of the game, then you can predict it. Probably you want to do something like that. I don't know, that looks like several parabolas, which makes sense, right? In our game version of the game, it's much simpler. We just go up, and we can let ourselves down a bit, and like that. But the important thing is that we want to go up or above each of such points. So if you think like here, you want to be at that x position, you want to be at least here. So this is a valid interval. If you don't click, then that interval gets transported one higher, and then you can intersect it with the interval of that thing. Here, for example, did I just do it wrong? Do we get higher or lower? That's the important part. So like obviously want to cross all of these intervals. There's minimal number of clicks. I think we can get rid of shadows pretty much just leave the points. Probably could have just started coding and it would have worked, but that's something you want to do in an educational screencast, right? So here's a point, and you want to be there. Somewhere there you want to be. And of course there may be bigger distance between the two. So let's get rid of some of them, just because I can. If you don't click, then you can come from here. If you click, then you can come from here. Oh, okay, so like if you want to get here, then you can come from pretty much anywhere in that range. That's like 45 degrees range. But you want to come at the lowest possible point, including what you will have later up the road. Here you don't want, you usually want to go to the lowest point, but then you won't be able to pass the next obstacle. So first of all, what we do is we iterate over obstacles in reverse to adjust all the obstacles. I think it's gonna be much cleaner this way. So not from here. From here. So HI gets what? Let's think. It's maximum. Clearly the obstacles can only get her of what? HI obviously. And HI plus 1, so the next obstacle, minus what? Minus distance between them. And distance between them is xi plus first minus xi's. So what that means that some obstacles artificially got larger. And now these points kind of align. There's such line, there's such line, and they should have 45 degrees, but I'm not good at drawing, so. What do we think about next? Want to minimize the number of clicks. So we want to be at the lowest possible point. Essentially what we want to know is how many clicks will we need between every pair of, C stands for clicks, between every pair of points, and I assume that we can compute it just in the further talk. Don't have to do anything smart except for, okay, so count clicks between xi hi and xi plus 1 h plus 1. Plus 1. Plus 1, not that it really matters, but okay, so what is the minimum number of clicks that can get us through that obstacle? Imagine we have k clicks, then what will be our height? There are that many not clicks, right? So that's how much down we go. Also we go up plus k. Want that hi, so our initial height, plus number of clicks minus number of non-clicks is at least this from here after you get rid of this. Also carefully convert everything, that is 2k. This is going to be positive, this is going to be negative. Yeah, so when you want 2k to be at least that, or k to be that, running up, of course. And probably you don't even need this. Or do you? Try to think. Probably did it wrong. Probably have to account for our current position. Okay. So change of plans. It's really similar, but we're going from xh plus 1 to xi hi plus 1. Because we also have to account for initial sync, and that is the way that I thought about. Which is probably not that good. Because x is the name of the vector. And h is the name of the vector. So h current, x current. Makes some sense. Not a lot of, but so current height is initially y, and current x is initially 0. So to make the obstacle, I want at least that many clicks, right? Make to the next obstacle. What? No. These are also important. Yeah, like this way we know that if we make the current obstacles, and we make all obstacles after it. Because current obstacle kind of includes the information about all obstacles after it. So if k is greater than xi minus xc, and it's impossible to pass. If k is less than 0, so we don't need clicks, I'll just set it to 0, I assume. Then what happens next is current x gets set to this, current h, however, gets set to what? Should increment it by k, we should decrement it by minus xc, before xc changes obviously, minus k. That says how many chances we had to click. That is how many times we clicked. So this is the number of times that we did not click, and that's total decrease. So you can say that what actually happens is as follows. Sounds kind of reasonable. Let's see if it actually works as I intended. What is it? Flappy something. Oh, because you want to get there, I assume that number of clicks is correct. No, you want to get from here to there, actually. +1 is still running up. Guess you're wondering what it does there, and it's running up. It's kind of hard to see what are the actual values. I assume that this for some reason is 0, which it shouldn't be. To 1, it's for some reason it is just 0 because oh my. Not being very cautious today, I don't know. So 2 to -1, not the best test cases in the world, but I kinda don't really want to come up with more. I hope nothing is long in this problem. Yeah, don't tell me that it's because something was long. It may actually be, if you think about it. Okay. Because we are updating constraint, I don't really know. It should not be. It should not be. Oh, but I'm stupid, right? Because I'm stupid. I return whether when I should not return. Classics. I mean, I did it already several times. It's just so stupid trying to be smarter than what I am. Just to show you what the problem was, like, I need to take that and say this test case is now first test case. See? It ends after the first failure, which it shouldn't do. It should not do, really. But then at the start of this, we can actually have a nicer condition when we just because we did that, we can say, we can tell if it's got to be possible or not straight away. That's the very first point. Yeah, now you can see -1, so. Sorry for not being very cautious. Rather should be more careful. I don't think that lungs make any difference, to be honest, because I don't think that lungs make any difference. What the heck? Julia. What? I don't get it. I don't get it. We are never. You see, the strategy that we follow is to never overshoot. One of the minimum positions that we can be at, given all the remaining obstacles, we are never getting done without a good reason. But at the same time, we never overshoot. We take just enough. Like I already make everything long so it can't overflow. If it's negative, then I don't care, I think. If it's negative, then I don't care. Like about which way the rank goes. Oh wait. No. Like, surely that can be. We have at least one obstacle. We are going to pass it, so we can't die off hitting the floor, really. So. Yeah, it says that the height should remain non-negative, but like our solution achieves that. Imagine that we are here, we want to get there. You say like minimal number of clicks, take something like this. Okay, you say, what if I told you that we have that? Well, you think, okay, I'm gonna do this, right? But no, like what you're really gonna do is you're gonna go forward first, upward first, and then you're gonna fly down. Because you're always getting about that point, and you're never getting hit the ground, right? So we don't hit the ground, not at all. I don't get it. Everything is long, so nothing overflows. We incorporate all obstacles to come into the current one. Why the honestly, like I explicitly put parentheses there to not make that mistake. Okay, imagine that we have two obstacles, I guess. Yeah, we start at height, I don't know, 0. And the first obstacle is at position 10, the second is at position 20. Let's say the first one is 1 height, second one is 20 height. Well, okay. 1, 2, 0, 10, 21, 15. says that it's impossible. It says it's impossible. But it's not true. Because we incorporated objects wrongly. So 1 to 0, 10, 21, 15 is actually 18. Okay. Yeah, I just thought that I opened the parentheses and therefore I put positive sign there, whereas I should have put negative. I should have just said that xi minus xi plus 1 minus xi is equal to di, and that should have saved me some errors, because I'm doing this like in a couple of places. Here, there. And it's easy to get lost. Yeah, because it really should be the distance. It's like how much can you go up to get there. Okay. Problem chef inquiries. In a sequence, we want to handle Q queries for each I from L to R at x squared plus x plus I minus L squared. So you're adding like a parabola in. Such a bad problem, honestly, really. No, like it's kind of obvious that you'll have segment tree with 3 values at every cell. It's just such a stupid problem. I don't know, the only place in the world where people like such data structure oriented problems is India. I don't know why. I never get it. Like, in my personal opinion, it may sound harsh, but algorithms are not about data structures. Data structures, like, you kind of use them as a black box. They provide some operations, and it's nice when you have to use something non-trivial to actually get your data structure to work, but this is just such a common trick that it's not even a good beginner problem that actually teaches you about something. It kind of throws you as a beginner at the fact that, well, there is a segment tree that you got to learn to perform well, except that it's not true for most of adequate platforms like CodeForces. You may need segment tree in Div1, but you never ever need segment tree in Div3, and you rarely need it in Div2. And those people who just bash Div3 problems with segment trees, I have nothing good to say to them. Like, you're not doing it the right way. I just got cited now. Can't just ignore that simply. But yesterday, Alexei Daniluk, who is Omnic, of course, posted a blog post, and he's talking about things he does not know, and there are lots of data structures in it, and it, like, I imagine that a lot of users from certain countries, they know Lichao tree and Katri and sort of stuff like that, but they can't perform well in competitive programming contests. He's saying, like, if you know at least 3 of those things and you're not right, you're doing something wrong. And I completely agree. A lot of data structures that CodeChef forces you to know you don't need them in normal worlds. And by normal worlds, I don't only mean code forces, I mean also AdCoder. Never seen a data structure oriented problem there. Never. Whereas some platforms like Hacker Earth, which is also sort of Indian, I assume, you also have segment tree problems there. They are just plain segment trees. I remember in 2017, CodeChef actually had a good segment tree problem. At least it was good for me at that time because I did not know that you can use segment tree with a Taylor series of a logarithm to get segment tree to answer logarithm queries. The original queries were of course not logarithms, but like you wanted to compare products of two subsegments. And the way we did it, we said like, okay, we're gonna take the logarithm of everything and then take first 20 elements of the Taylor series of a logarithm, and it was precise enough to give us a good understanding of which one is bigger. But like that was at least, it combined two ideas. Here it combines kind of the budget version of that idea when you have quadratic function which you represent as quadratic stuff. And I also think that I was wrong when I said that it's segment tree because you can do the same thing with Fenwick tree, but still, I'm still not impressed by that problem. Yeah, because it is just what it is. It can transform, of course, because of the duality in Fenwick tree. You can do that. Nevertheless, terrible problem. Would never recommend it to a friend. I don't know who likes such problems. I mean, they're all similar. You do the same thing. It's not even like you have to apply Moss algorithm to, or not apply like a persistent segment tree, which is kind of for higher rated people. You just, depending on how good you are with segment trees, you either, or rather depending on how good you are with Fenwick trees, you either apply them or you apply segment trees. Terrible problem. Bro. Okay, there is type of a query. I don't know who was the genius who decided that Y is a good index. Why, honestly. Oh, I actually know who was, right? Oh, he's a tester. Yeah, you see, like, bruh, 2-star coder setting problems for me? No way. Like, that's, he simply can't, it can't be interesting. Like, previous one was set by a 6-star coder. When a 2-star sets problems for div 3, doesn't make sense. They can't possibly know what a good problem, what a good educational problem is. Because I often face the situation when I know something, but I can't actually teach others about it, because I don't know it well enough. I just don't. And then you like to be able to set an educational problem or explain something which is more or less the same thing. You need to know something significantly better. You need to know a lot more about the data structures to set good questions about them, which is not happening at the moment. You may think that I'm a little bit too critical, but I don't see a single reason. Like this guy, did not provide me with any reason whatsoever to go easy on them. That's a bad problem, and I'm gonna say it out loud. And I can copy paste my templates of fan victory, but I don't think that it will help me a lot, except for probably indices. It's not going to help because I didn't call it, so that's what this means. Yeah, so the interface is fixed now. We just have to implement everything that we have to implement. What does it look like? Imagine that we add an a constant. What should actually? If we are adding a constant, then I probably should do this, right? Yeah, show this. Okay. If we were to add a constant, it would be something like that. We add it here, we subtract it here. Right? But we are not adding a constant, we're adding a quadratic function to it. And a quadratic is a bunch of constants, if you think about it. Yeah, something like that I was thinking. Range of dates and point query. Yeah, I should just say that it's point update at all. Okay, then r plus 1, I assume, minus x, okay. Is it gonna work this way? I mean, it has to, right? Oh. What is that shit? Oh, because you're using one-based indices. Goodbye, then. What? I mean, that's more fast. It's faster, I assume, but it is just so marginally faster that I don't want to get into that. Segment update. Just take segment update. Okay, that's range increment exactly. And no, and I got e or y plus 1. t0 at I gets incremented by x. Let's add any constant. Then adding quadratic function will going to be a bit more complicated, I guess. Sorry. This is not the way I wanted to spend my afternoon. Also because I still, like technically I still do not solve the problem, right? Because I constantly forget what is the exact translation between these two guys. But surely you want to do something like that, so. What is going to be added to AI? So AI gets incremented by this. What is this? It's x squared plus 2xi minus L plus I minus L squared. This should be the constant, right? Right. Like the actual variable here is I, or I minus L, or I. I need to spend a long time here figuring out the details. Now here I think that Ti. Oh my goodness. Why is it so complicated? No, I think this is the wrong approach to that problem, right? What you really want to do is to actually say that you get 2x squared minus 2xl plus L squared, and that's your constant. Or T0. Then you also have 2x minus 2L times I. This thing is your T1. Then you also have I squared. There's an invisible 1 which is actually equal to T2. So you regroup, because I is the actual variable. Once you've done that, we should be able to solve the remaining problem. So like actually, we store the coefficients. We store the coefficients. So we want, okay, this is going to be just very stupid problem. Yeah, then that will be it's going to be very stupid. So J is actually the index of Ti. Because we're gonna do that. Now the reason why I want this is because this is the constant, right? Here I should pass the constant. The constant is this minus 2 times this times this plus this times this. Not the most prettiest one. Then this is actually less painful. Oh, this you can regroup, right? It's x minus L squared. Of course. Yeah, we just expanded this, treating only I as a variable. Obvious. Should have done it from the very beginning. Update 1 LT1 1R plus 1 minus T1. You update, finally update 2L1 plus 1. If you really want, so we can do it like that. Got rid of this. Like this updates specifically the part that it needs to update, right? Get at I, therefore. Okay, then here should call update from the constant of I no AI something like that. Okay. It is a bit bad design, so what we're gonna do instead is we're gonna say that's our coefficients. Or like that. Because then we can write code like this, which is undoubtedly better. Of course 3 also can be replaced, but not now. And here goes the J's coefficient. Yeah, like less chance of making a mistake. Here also you want to restore coefficients. You can do that, right? That sounded too good to be true. But here we have to actually restore the actual value, which is C0 times C1 times I plus 1, I assume, because indexing is usually from 1 in the statement. Clearly nothing of this is going to fit into standard. Sounds reasonable, I don't know. Maybe not gonna work probably, but at least it sounds reasonable. It's an error. Because I assume that I never said that k is going to be 3. $39 and 41, which is not enough. What did I do wrong? Maybe I should ask for this value, not really sure why, but I may have made that mistake. Clearly not, because you can see that it's went wrong. Or did it, actually? Yeah, it's wrong. I probably should have also done this, right? At least it makes sense. Well, now answers are even smaller. Okay. Oh, this is wrong, great. I should do it differently. No, I should do it here. I should just do it here, right? And also here. to make sure. Yeah, that's the best way to debug data structures. Hmm? Can don't do it or do I not? Oh, it can't be const because get is not const. Actually, get can be const. Yeah, that was not the correct way to fix it. Not the right way. It was, of course, correct. Wait, why is that negative? Oh, I think it's actually that kind of works without being one longer. So, our initial array is 110,365, which is kind of nice. That's at least our original initialization, but it reads. Then we say we are adding from 1 to 3, we are adding the 5 sync. Through the first sequence, it should get to 26, 46. Okay, so we are not processing updates correctly, obviously. Because this got correctly, and then it went wrong. So the constant we added was correct. Then it went wrong. Why? How did that happen? 2 times x minus l times I. Probably there is l plus 1 or something. Not really sure what went wrong here. Okay, now, so the constant was correct. By the way, I don't know why. It looks like it was. Probably because both I and L are one smaller in our version. We'll see, we'll see. It's not growing fast enough because the first entry grew enough, which means that constant update is correct. The constant is correct. For some reason this is not correct. You see, we're not doing anything valuable in this problem. Wait, what happened there? surely you don't have to do that, right? I'm a bit puzzled why this makes no difference. I recompiled it, right? Definitely did. I changed the coefficient, but it made no difference. How is that possible? Yeah, just ended 25 to all of them. I don't get it. Something's wrong. So our tree is not adding anything for some reason. Here, 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 as it should be. I did something wrong and I don't know what. And unfortunately, even when I figure out what I did wrong, I will not get any new knowledge apart from how not to make stupid mistakes in Fenwick tree. Not that valuable. This is initialization. This is updates. There are updates here. There is some value being passed in, so like 10 for example. And the tree is updated just as normal. Right, it's just a different tree. How does it went wrong down here? Boring. So it said it's C1 and C2. Whoa, because I'm stupid. God damn it. Of course, we can't do just this. Okay. Useful. Not really. What? I mean, and declares. Oh, right. Sonank, okay. Now we are getting too much. Probably because we should not actually add it here. I feel like we should not. Like it should be uniform everywhere. Not good. 5269. Because we're really past it here. Boring. And not good. This is not a div3 problem. You have no idea what a good div3 problem is. Please take a look at color beginner contests, excluding geometry. Then you're gonna get good at problem setting. I mean, let's take a peek at the rankings of div3. Okay. Yeah, you wait, what? Flappy Bird is a complicated problem for them? What is going on? So chef and queries, okay, like you can see that chef and queries, like 17 people can solve it in div3 out of 272 pages, which amounts to around how many? 40 pages is 1,000 participants, so 280, around 7,000 participants, and only 17 people can solve this. Even though it's not a segment tree, technically it's Fenwick tree, which is much nicer to implement, but still. Yeah. For some reason they also think that Flappy Bird is a complicated problem. No idea why. It's super easy. But likely for us, like they actually think that total correct submissions is an easy problem. Maybe the order is just wrong. Where am I? Where am I? Surely I have 5. Okay, I have 500. But yeah, I just solved problems in the wrong order. So this one's gonna be easy. CodeChef challenges have 3 divisions. In one division there are n problems in one challenge. There are n problems in each division. But some problems may be shared among multiple divisions. Such problems are uniquely identified by a code, we know. String containing only uppercase English letter. That's not correct. This is problem blitz 3_2. No, neither of 3_ and 2 is an uppercase English letter. Each participant can only submit in one of the divisions. That is correct, because it checks the rating. Chef wants to find a number of correct solutions and total among all 3 divisions for each problem, given a list. Yeah, that's just implementation. Okay, first line, that's number of test cases, and you have n. What's going on? Okay, here we go, here we go. This is just, okay, whatever. So count of this gets incremented by this. What happens next? What happens next? What actually happens next? No, this will be ordered wrongly, so I'm gonna do instead, so I'm going to cast it to a vector of pairs, and I'm gonna sort what if several problems have the same frequency? Or we only print numbers? Something went wrong. I don't care if this is true or not, but I probably should change that. It sounds like I read the input in the wrong order, but I don't understand how that could have happened. No, it's 1, 2, 3, 1, 1, 2, 2, 3 hands. Also, I made everything long, not to care about like some of such values overflowing. Implementation problem. Can't say much. Yeah, easily. Therefore, wait a second. You can probably tell that these guys are getting bands. unless, or probably not actually. I think that they are members of some team. That's why they have such strange usernames. Because the submission order is just random for both of them. It's not the same. Anyways, I think I actually made a good job explaining everything already. Just to give you a quick look, so simple implementation. You just want to know that an ordered map can count stuff. Simple implementation with an observation that's like the times that you spent is total times that you got minus what you have in the end. Here, observation, that's actually, they told you that in the statement. So here, well, that's probably was Q5, P5, right? Here, more or less simple observation, because you really want to say like, well, I can take anything that reduces my remaining time and don't take anything that remains. Right? So yeah, that's how it is. It is an interesting question how one may minimize the total sum of chosen CFs. I find it very fascinating. Obviously, you can do it with DP, but that's an open question for you guys. Minimize sum of taken slip lines it's not yeah, we're gonna say it's challenge. It's challenge. Hopefully I can write. Yeah. Slip lens. Slip lens. You can do it with DP, but that's gonna be like off NH and LH. Still not very good. It's not what to do. Apart from that, I don't know. It's probably soluble in N-Logana, like pretty much everything is. But I'm not sure how. That's an interesting question. Here, Flappy Bird. I kind of know that thing from a YouTube video that I watched. I don't know, like when Flappy Bird was popular. I watched an explanation of how bots actually play very well. And I thought about that immediately, like you have shadows that you can't go to because you will lose, even if you don't lose immediately, you will lose later. And the way to get these shades is like whenever you encounter new objects, you recompute from with a sweep line from right to left. So this is a good problem, absolutely. Very beautiful. Where is it? Where is it? I want to say thanks to the author of that problem. Yeah, you can say. He's unrated. But surely you can find him on CodeChef. He is not on CodeChef. I don't know how this is happening. That's very interesting. Wait, is it? No. Okay, I don't know who he is, but that's a very good problem, in my opinion. it's algorithmic. You have to think. Solving backwards is common idea, but very nice here. And then you just have to be careful with your implementation and not like return from main here. So that was a nice problem. That was not a nice problem. It has no education. Like, unless this is the first time that you see this trick. I don't know. Also, this can be improved because currently it's kind of ignores k. Also, what you can do is say like x is 0, then for in reverse. I'm showing this because this is actually an important trick to know how to quickly compute polynomials in linear time. Because this takes quadratic time if you have more values. What you do is you multiply it by variable, then you increment it by coefficients. Okay, 7th place. I assume it's because we have some penalties, but I'm not sure how the penalties work here. I just wanted to quickly check that. Yeah, 52.69. So I just wanted to generalize code finally. That's the best you can get. So this way it works not only with quadratic functions but arbitrary polynomials, and as I discussed of this degree. And as I discussed earlier, plenty of analytical functions can be represented as their Taylor series. But like this is a textbook question. Don't think that it's a good fit for a contest. Especially if it was not implementable with Fenwick tree, then I would say that it's a terrible fit for this contest. This time, I actually feel like it's better than the previous time. As you can see, in div 3 for them, for some reason, the hardest problem is Flappy Bird. I have no idea how that happens. And then there's only one normal Finnish guy who can solve algorithms but can't do data structures. And everybody else, they just know how to code data structures but can't solve actual problems. Not good, not good. Stop learning data structures. They're not going to give to you more than one question in a contest. That's for sure. Like, out of 6 problems, 5 are algorithms and probably 1 is data structures. Not worse. I would rather be that Finnish guy than any of these Indians. I don't know, this is not like inherently wrong with any nationality. I assume it's because how the education works. Because CodeChef, Hacker Earth, and other platforms, they advertise for data structure problems. Therefore, you get people learning data structures, not understanding how algorithms work. This is a flaw of preparation system. you can see that 200 people can solve a Fenwick tree stuff-ish. Probably they also solve it with segment tree. Only 6 people can solve Flappy Bird, but if you compare, like, it's pretty short, right? I didn't do like too much. I didn't say that it's a class which has private and public fields. I don't have any white space. So. In Flappy Bird, I have white space to separate things logically. And it's still like, this is just so small. Probably can get rid of this with the 1 check here. No, like, there's no way you're solving this if you don't know what a Fenwick or segment tree is. This is kind of sad. Like, here there are many approaches. For example, I could have removed, not modified, but removed obstacles that don't make any difference. Could have. I could have done it with a different sync without keeping current x and current height. I had ideas how to do it differently. Like that, you can solve this problem in a variety of ways. Here, Fenwick tree or segment tree, neither of which is particularly beautiful. It is a useful trick to know, but not for a diff-tree competitor. You have vast majority of people not solving slip cycle, which only requires you 1 observation to make. Like, what is it? I just really wanna know. That many people. So, for 5% of people can make this observation. And 4% of people know how to code Fenwick tree. This is just not the way to go. This is just bad. Forget about data structures until you are a candidate master on code forces. Apart from, no, just forget. You don't need them, I believe, until candidate master. Like, I myself know well only 0 data structure. No, actually. Okay. I know this joint set union, Fenwick tree. I kinda know how segment tree works. I can probably code it without looking too much into the reference implementation. That's it. Okay, square root decomposition, but I'm pretty bad at it. It's like, I just use it when I don't want to code segment tree, whereas I actually should just code segment tree. So I know square root decomposition for historical reasons. That's it. Most of the things that you can make with segment tree. Okay, not most. A lot of things that you can make with segment tree while being a candidate master on code forces can be also done with Fenwick tree as recently. Which one is better? Of course, segment tree. Which one you should know? Probably Fenwick tree and then segment tree. Although I may be biased. Like, Fenwick tree does not use a reasonable idea unless you understand how bits work very well, which you probably don't when you're not in D1 code forces. Okay, it's a complicated question. I did not expect myself to get into philosophy of competitive programming that much. So, anyways, hope you enjoyed. I hope you learned something new. B7 this time. I've seen that previous time, we can actually check, but I think that previous time I was only 10s or something like that. Still, like only 3 people solved everything, and for them the most complicated problem is Flappy Bird. I just can't wrap my mind around it. Okay, maybe, how about div 2? Maybe div 2 is not that bad. Dude, what's Flappy Bird? Okay. I must be very stupid, but I don't get it. Only 9 people solved everything. And there are normal people and people who know data structures, but not algorithms. Okay, there are algorithms people and data structures people. Both are normal, of course. Speaking of which, I promised you to look up our stats on CodeChef. Where is it? Also, yeah, like Flappy Bird is apparently the hardest problem. Don't you look at that? Okay, so I mean, it's smaller than div 3, whereas this number is not much smaller. Wait, is it also the case that Flappy Bird is the most complicated problem in div 1? No, like in div 1 people are more algorithms oriented, and that's how you determine when you're doing things wrong. If div 1 people say that it's simpler, that it is simpler. You should do them in that order. Should not do them in reverse order. Of course, participation is just low. We have like 2 ranking pages. So pretty much everyone solves these problems, and like half of people solve this problem, quarter of people solve this problem, mostly because they got tired doing something stupid. Yeah, we've been 10th in May starters. We are 7th this time around, and hopefully we can. Yeah, I participated in June challenge, didn't really solve anything after like the initial time, so that's why we have this. I'm just close. Like every time I lose rating, it's because it's a long challenge that I came to and then forgot about it. Also, the random changes appear to be broken. No, honestly, every time I lose rating, it's because it's a long challenge. I never lost rating in a short contest on CodeChef. Funnily enough. So hopefully next time we can get even better than that. I hope you enjoyed the solutions. I hope you find them educational. And with that, see you next time around. Bye bye.